take a while?
Because this is a review. It should be a review. You factored before, right? You started factoring in Algebra 1. There's four different types of factoring, and I want to go over 15 of them, right? You have a front and back of factoring. We're going to do 15 of them. The rest is going to be for you to factor by tomorrow. Okay? So these are the first four I want to do, starting with this one. And the first way of factoring is reverse distribution. So what does that mean? That means if I had a distribution problem, something like 2x, and I want to distribute 2x, something like this, how would I use my distributive property? I would take the 2x times each term, right? And I would get 6x squared minus 2x. So factoring using distributive property means instead of starting with this, you're going to start with this right here and say, what can I factor out of both terms? So I think, okay, 6 is 3 and 2 and 2x's. 2 is 2 and 1 and 1x. So I can circle a 2 and an x out of each term. What's left in my first term, 3x. What's left in my second term, 1. And I get this. See how I just went backwards? Instead of here and distribute it through, you're starting with the answer and say, what did I distribute through? That's factoring. You're factoring out that common term.
You just got to the same thing.
That's what we're doing.
Wait.
Okay.
How's that doing
Right.
anything?
Let me show you. So if I start with that, let's say this one right here, right? So 25 is what? 5 and 5.
5 and 5.
And 2 x's, x squared. 35 is 7 and 5. What can I factor out of both terms?
5.
A 5. Do they have x's in common? No. So the only thing I take out is a 5. What's left in my first term? 5x squared. What's left in my second term? Negative 7. Okay. So if I were to take this 5 and distribute it, I should get that as an answer, and I do. That's how you can check yourself. Okay, let's try another one. So I have 3x squared and a 9. So we know 3 is 3 and 1, right, and 2 x's. 9 is 3 and 3, so what can I factor out of both terms?
3.
A 3, very good. So this negative's still there. So negative x squared plus 3. Okay. Now, when we're factoring, if you can make this a positive 1, you should do it, and you'll see why later when we start using this to solve. So I would also want to pull out that negative. And if I pull out a negative, that'll change the sign on both of those. Right? Because if I'm going to pull out a negative, that's going to become positive. If I pull out a negative, it's going to become negative. Okay, so if you ever have a negative in front of that x squared, pull it out. Okay. Let's try another one. So look at here. This one, x squared is x times x. And this is 2 times x. So what can I factor out of both terms? X. So x comes out. What's left in the first term? What's left in the second term? There you go. Okay.
Why wouldn't the x in the parentheses be squared? Because there's 2 of them left.
I'm taking 1 out. So how many are left? 1's left. So look at what happens when I multiply. What's x times x? X squared. What's x times negative 2? Negative 2x. All right, let's look at this one. This is a 2 and 2 x's, right? 50 can be 2 and 25. So what can I can circle a 2 in both, right?
They're gone.
So what's left in the first term? What's left in the second term?
25.
Okay. Now this is going to lead us into the next type of factoring. The next type of factoring that we're going to look at is called difference of squares. Difference means subtract. Whenever you're subtracting 2 perfect squares, you can factor that one more time. Okay? So what squared is x squared? X. What squared is 25? 5. So it'd be plus 5 minus 5. called difference of squares.
Do we need to write that out too?
So let's go down to the second part. And first of all, let's review all of our squared terms.
Where are you?
1 squared is 1. 2 squared is 3 squared. 4 squared. 5 squared.
25.
6 squared.
36.
7 squared.
49.
8 squared.
64.
9 squared.
81.
10 squared.
100.
11 squared.
121.
Whoops, my marker. My marker. I was going too fast for my marker. 12 squared.
144.
13 squared.
169.
Those will probably be the squared terms that we'll see. You probably won't see anything bigger than that, okay? So whenever you're subtracting 2 of these, right, with just an A term and a C term, notice on all of these there's no B term. There's no just X term. I only have a squared term and a constant term. And you're subtracting 2 perfect squares, you can factor by difference of squares. So let's look at this one. Okay. What do I square to equal x squared? What squared equals 64? So I'd go plus 8 minus 8. Let's try this one. What squared is 25x squared?
5.
5x. So it'll be 5x and 5x. What squared is negative 4? 2 and negative 2. Okay. Why does one have to be positive, one have to be negative? Because it's a negative 4. Very good. Okay. And the other reason would be if I FOILed this, first, outer, inner, last. See how my outer, inner are exact opposites, so they're going to cancel out? That's because one's positive, one's negative. And it also makes this negative 4, right? In order to get a negative number, one has to be positive, one has to be negative. Okay? But that's why it's opposite signs, so these outer, inner terms cancel out. Let's try one more. This will be number 7. So what squared is 144x squared?
12x.
12x. Good. What squared is 100? Plus 10 minus 10. Okay? So here's the thing with factoring. If you're going to factor, you always kind of want to look first, right? Is there something I can factor out? Okay? And if you don't notice at first there's something to factor out, once you have it factored, you should see, can I reduce that more? So now think of your distributive property. Can I factor something out of 12 and 10? What can I factor out of? I can factor 2 out. So see how this simplifies one more time?
Do we have to do that?
Okay, so I ended up factoring out 2 2's, which 2 times 2 is 4, and now it's factored completely. Okay. So sometimes that'd be easier. Oh wait, one of these would be subtraction, right? Oh, whoops, I messed up. Hold on. That should be minus 5, and that should be a minus. There we go. Okay. So in the beginning here, I could have noticed that, oh, they have a 4 in common. I could factor that out first. But if you did notice that and factored it, you still always need to be looking, is there something else I can factor out? Do they have something in common? Okay. Now for standard form factoring. You should notice the first half of this page, all of my a's are 1. So you have a 1 in front of x squared. And on the bottom half, I don't have a 1 anymore. I have numbers. So there's 2 different ways to factor here. Okay, if a is 1 and if a is not 1. Whoops, too far. Okay, so if a is 1, which ones did I want to do here? I wanted to do these 4. 8, 9, 10, and 11. Those are the ones I want to do for example. All right, so this one, what do I multiply equals negative 36, but add equals negative 5?
6 and negative 6.
No. 6 and negative 6 added together is 0.
Wrong.
9 and 4, which one's negative?
4.
No. Negative 9 and positive 4 because I need a negative 5. So it's got to be negative 9 and a positive 4. So then it factors x minus 9, x plus 4. One more. What do I multiply equals 2, but add equals negative 3?
Negative 1, negative 2.
Very good. A double negative multiplying is positive. So a negative 2 and a negative 1 equals positive 2, but added together is a negative 3. So it factors x minus 2, x minus 1. Good.
Please.
All right.
Carry on.
When A is not 1, okay, I'm going to show you 2 ways to factor. The first way of factoring is using mental math, and I really encourage if you plan on going into pre-calc, calc, something with math related, maybe in college, you need to factor mental math so it's faster. If you don't plan on doing that, right, and you just do this, maybe stats finite next year, you'll be fine. I'm going to show you a little bit longer approach. Okay? So whichever one you want to use, but I'll show you both ways for each one. Okay? So here we go. When you don't have a 1 here, you have to do FOIL in your head. So to get 2x squared would be my first terms multiplying. So I would know 2x times x, that's the only combination that if I did FOIL, first, outer, inner, last, 2x times x would give me 2x squared. Okay, so now I'll try to show you what I'm thinking in my head. I have to think, what 2 terms here do I multiply 15, but outer, inner gives me negative 11. So I just start going through my numbers, like 1 and 15. Well, that's 30 and 1. I can't get 11. 15 and 1, that's 2 and 15. I can't get 11. So then I try 5 and 3, that'd be 6 and 5. Oh, there it is. 6 and 5, I can get 11. Because negative 6 and negative 5, outer, inner, gives me negative 11. And negative 5 times negative 3 gives me positive 15. Okay. So that's mental math. Now, if you don't like that, I have a better way. Okay. So you start with your quadratic. Okay. Now, we know that if this A term was a 1, I can just use the factoring question. What do I multiply? What do I add, right? So let's make it a 1 by taking it into the C term. Okay? So you multiply the A term by the C term to get A to be 1. Okay? So you're taking the A away. And then you're going to say, okay, what do I multiply equals 30, but add equals negative 11? Negative 6 and negative 5, right? So then you factor x minus 6, x minus 5. But now, since the A term went to the C term, you have to bring the A term back in. Okay, so the A term goes away, but then the A term comes back.
Easy.
Can I factor anything out of 2 and 6?
Yes.
A 2. Can I factor anything out of 2 and 5?
No.
No. And anything that factors out goes away, and now it's factored. So see how it's the same thing, but this approach is going to take you a little bit longer to do.
Which one is?
The second one. So let's try another one. Okay. So let's look at this one here. So I know 5x squared can only be 5 and 1. So 5x and x. Okay. Now, mental math, I want to think what outer, inner, would I get 28, but last, right, FOIL, first, outer, inner, last, would give me 32. So start trying some things. 32 and 1. Does 35 and 32 give me 28? No. So what else? 4 and 8. Does 40 and 4 give me 28? No. 8 and 4? How about 20 and 8? Oh yeah, 20 plus 8 is 28. So I would go 8 and 4, both positive, because that'd be 20 plus 8 is 28, and 8 times 4 is 32. So if I FOILed first, outer, inner, last, I get that quadratic. So I factored it correctly. So let's look at the longer approach. Okay. So what I'm going to do is take the A to the C term, and that'd be 150 plus 10, 160. Okay. So now what do I want? What do I multiply equals 160, but add equals 28. Okay. And 160 is pretty big, so I would start a factor tree on this one and start thinking, okay, 160, 16 and 10, no, can't get 28. How about 4 and 40? No, can't get 28. How about 8 and 20? Oh, there it is, right? Just start doing factors of 160 until you find it, okay? So that would be 8 and 20, 8 times 20. So it would factor x plus 8, x plus 20. But don't forget, right, if I took the a term away, I have to put the a term back in. Can I factor anything out of 5 and 8? No. Can I factor anything out of 5 and 20? Yes. But whatever factors out goes away. And then it's factored. And see how it's the same thing?
Excuse me.
All right, so let's try this one. 3x squared can only be 3x and x, right? Okay, so now you have to think outer, inner. What do I multiply equals 16, but outer, inner is 8. So let's do like 16 and 1. Does 3 and 16 give me 8? No. So I can do 2 and 8. Does 24 and 2 give me 8? No. 8 and 2. Does 6 and 8 give me 8? No. How about 4 and 4? Does 12 and 4 give me 8? Yes.
Wait, so you which one?
4 and 4. Because 12 minus 4 is 8. So that would be negative, that would be positive. Nope, other way around, isn't it?
Oh, I had it right.
Positive 12, negative. Negative.
And then you're done. Forget this.
Because since it's a positive 8, you have to have a positive 12. The bigger has to be positive. 12 minus 4 is 8. Nope, then you're done. Okay, the other way, let's look at that again, would be to take the A term to the C term. And let's see, 30 plus 18 is 48. Okay. So what do I multiply equals 48, but add equals 8? So maybe you'd have to use a factor tree and think, okay, 2 and 24, 4 and 12, and there it is, right? 4 and 12, positive 12, negative 4, positive 12, negative 4. So I would factor, but if I took the 3 term away, you have to put the 3 term back in. Can I take a 3 out of 3 and 12? Can I take anything out of 3 and 4? And anything that factors out goes away, and now it's factored. Okay. So again, same thing, just a little bit longer. Let's look at one more, just to make sure we got it. This is going to be the one that gets us throughout the whole school year, is when A isn't 1. It's the hardest one. So my last example,
2 and 6.
well, I have 7, right? So what outer, inner? So that would be 42 and 2. You can't get an 8 out of that.
What?
So let's try this.
What do you mean?
14 and 6. 14 and 6.
Where are you getting 14?
7 times 2.
What? You're not making sense.
Because my outer inner has to equal 8, right? So 14 and 6.
Oh.
14 minus 6 is a negative 8. So minus, plus, and then it's factored.
That doesn't work. The page just said it didn't work.
2 and 6 didn't work, but 6 and 2 does. Order matters on that. Okay. So let's do the other way. I'm going to take the A to the C term. So 84. What do I multiply equals negative 4, but add equals negative 8? So let's think. Negative 84. What do I have? 2 and 42. 4 and 21. What else? 6 and what? 6 and, no. 6 and 14. And there it is, right? 6 and negative 14. So 6 and negative 14, 6 and negative 14. So I factor positive 6, negative 14. But if my A term goes away, my A term has to come back. Can I take anything out of 7 and 6? No. Can I take anything out of 7 and 14? A 7. Anything that factors out goes away. So now it's factored.